All right, everyone. So we're going to start by looking at a new function and how to transform it, a new graph we're not very familiar with. So this function is called the root function. So it starts as the square root of x. And let's look at the key points of the most basic version, f of x equals the square root of x, and what that parent graph looks like. And then we'll look at how we transform it. The process of transformation is the exact same as it was for quadratics, exact same as it was for those nonsense graphs we were working with. It's just the parent function is a little bit different, and we'll see that here. So we're going to start by making a table of values. And for these x values, we could try to put in whatever we wanted. You might notice that if we put in negative numbers, we're going to have a problem because we have to take the square root of them. So instead, we're just going to pick x values that are really easy to take the square root of. That would be the perfect squares. So let's start with 0 because we can easily square root 0. Square root of 0 is 0. And we'll continue. The next one that's really easy is 1. The square root of 1 is 1. The next one that's easy, like 2 doesn't square root nice, 3 doesn't square root nice, but 4 does. So square root of 4 is 2, and the square root of 9 is 3. Okay. Now we could have used other ones, we get some decimal values, but these are the easy points to graph that give us our basic shape. So let's see that now. So let's start with 0, 0, and then 1, 1, and then 4 on the x, 2 on the y, and then 9 on the x, 3 on the y. And you may notice this general shape looks somewhat familiar. Let me switch colors so we get a bit of contrast. So the general shape of this looks very similar to a parabola. Okay, and it's the same kind of shape as a parabola. It's just on its side. And it's only half of a parabola. There's no bottom to this parabola. Okay, so we call this the root function, and this is what the parent function looks like. Now, we're going to do some transformations of it. And remember, the transformations are all the same. We're just using different key points in a different parent graph to apply those transformations. So let's look at the second part here. So let's identify our transformations and graph for this one here. So let's identify them all first. So the first thing we've got here is we've got this half in front here. So it's outside the function. So it is vertical, affecting the vertical or the y values, right? So this is going to be a vertical, and because it's between 0 and 1, this is going to be a vertical compression by a half. And we might also write down how we do that algebraically. So that would be our y values, and I'm going to write it a little differently today, times 1/2. Okay. And what else do we have here? Well, we also have a translation. So it's outside the function. So it's going to be affecting the y values, or the vertical. So it's going to be up 1. Up 1. Okay, the next thing we want to do is we want to make our starting table of values for our parent function. So let's go x, f of x. So f of x is the square root of x. So we're going to use the same key points we used before. So the perfect squares and their square roots. You'll notice these are very similar values, just the x's and y's are switched for as a quadratic. Okay, and now we want to apply these transformations. So let's start by this vertical compression by a half. So we're going to have to multiply our y values by a half, but the x values, nothing's going to change. So we'll look at our x's and a half f of x. So our x values stay the same, 0, 1, 4, 9. And here we're going to get 0, a half. I'm going to write it as 0.5. I'm going to put some decimals in just because I think it's sometimes easier to graph with decimals. Half of 2 is 1/2. Half of 3 is 1.5. Okay, so let's start by graphing this function, and then we'll perform our last one of up 1. So the first thing I'm going to do, though, is I'm going to graph our parent function. So let's graph that. The more times we graph it, the more we'll unintentionally memorize it. So 0, 0, 1, 1, 4, 2, 9, 3. And let's see how well I can draw the curve this time. One other thing to note about this parent function is it only has an arrow on one side. It does not continue past 0, 0. Once we transformed, we might get some more points to the left or below. But there's never an arrow on this side. It doesn't continue. It stops there. Okay, so let's graph this 1/2 of f of x. So we have 0, 0 again. We have 1 in the x and a half in the y. We have 4 in the x, 1 in the y. We have 9 in the x, 1.5 in the y. Okay, so what does that look like? Well, it looks like a vertically, sorry, I'm having trouble drawing these curves. Vertically compressed root function. Let's see if I can clean this up a little bit for our notes. That looks a little better. Okay. So we still have to apply one more transformation. Maybe we should label these first, though. So this would be f of x. This one here would be 1/2 f of x. And the next one, the last one we'll do here is going to be g of x, which will be with the final transformation of up 1. So we're going to take each dot, move it up 1 from the blue one. So up 1, up 1. So note that that's at a half, so it's going to go up to 1.5. Since at 1, it's going to go up to 2. Since at 1.5, it's going to go up to 2.5. Okay, do my best to draw a nice curve here. It's a very flat curve. Okay, so this green one here is, maybe we'll draw an arrow to it because we're so crowded in there. This is our g of x graph. So it's been vertically compressed by a half, and it's been moved up 1. Okay, let's try another one. So we once again want to identify our transformations and graph. So let's start by identifying those transformations. So we have this negative in front of the f, and someone asked the other day, what does that mean? So whenever we just see a negative floating in front of something like this, there's always like a little 1 there, right? So it's -1. So there's no stretch or compression if it's a 1, but the negative does give us a reflection. So this is going to have it's an outside of the function, so it's going to affect the vertical. So vertical reflection. And to do that algebraically, we're going to take our y's, we're going to multiply it by -1. Okay. And the effect of a vertical reflection is to reflect over the x-axis. That's another way you might see it written sometimes, is a reflection over the x-axis. X-axis acts like a mirror, and we get a vertical reflection. Okay, so we have a translation here, so we're going to want to do that at the end. So let's write them in order. We have this 2. It's inside the function, inside these square brackets, and it's multiplying. So that's going to be a stretch or compression affecting the horizontal. So this is a horizontal. And 2, so remember when we're inside like this, we're going to have to flip this fraction. So instead of 2, it's going to be a half, which is going to give us a compression, horizontal compression by 1/2. Okay, and lastly, we have this -3 in here, x minus 3, and that is going to be a translation right by 3. And I forgot to write down the algebraic, what we do here for this horizontal compression. So the horizontal compression, so we have to multiply x by this value. So this is going to be x times a half. Okay. So if you want to write it out, x, multiply the x's by a half instead of writing it out like this, either is absolutely fine. The really important part is these like kind of sentences, these words, because they're just verbally describing what's happening with the graph. These are to help us get to the graph. So they're more for yourself than for me. Okay, so let's start with our parent. So x, f of x. This one, if we graph everything's not going to be as cluttered, so it'll be a little nicer. So our x value is 0, 1, 4, 9. F of x without any transformations is 0, 1, 2, 3, the square roots. Okay. We want to transform that with our multiplications here. So this is going to be x, our new x values. Let's do those first. So our new x values are going to be multiplied by a half. So we're going to get 0, 0.5. Half of 4 is 2, and half of 9 is 4.5. In our y values, so here we're going to have negative f of 2x. Okay. So our y values are going to multiply by -1. So 0, 1 becomes -1, 2 becomes -2, and 3 becomes -3. So we're looking back at our parent function table of values. And let's graph these both, and then we'll do our translation right to 3. So start with our parent, 0, 0, 1, 1, 4, 2, 9, 3. Draw our curve. Hopefully we're all getting a little better at drawing these curves the more we do them. That looks much better. Okay. Then we want to draw our one with our stretches, compressions, and reflections on it. So 0, 0, 0.5, -1. So that's going to be right there. Okay. 2, -2. Right here, make sure I'm at the right spot. And then 4.5, -3. Okay, so let's get that curve in there. And let's make sure that makes sense. So we're supposed to have a vertical reflection. I see that reflected over the x-axis. Looks good. And a horizontal compression by a half. Yeah, it's half as long. I mean, if we added more dots, it would be longer. These graphs go forever, but for our key points, it's half as long. Okay. Last thing we need to do is move right 3, but let's label these first. So this is our f of x. This blue one here, oops, is negative f of 2x. And now we will graph g of x. So we have to move each point right 3. So right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, one thing to note is that whenever we do the translations, the shape shouldn't change. If your shape looks different between your blue and the green, or whatever colors you're using, then sometimes it's an indication that you've misplaced a point. Okay, and this is our g of x. All right. So we got one more to do, and this one is in a slightly different form. For this one, we are starting with it in the radical already. Okay, so not a big deal. The radical is kind of the f of x part, right? So Let's identify what's inside the function, what's outside the function. So this 2 is outside the function, so that's going to be a vertical stretch by 2. Vertical stretch by 2, which means y times 2. Okay. Out over here, this is outside the function. That's going to be a down 2. Maybe we'll write that just lower down for now. Down 2. And now let's deal with the stuff inside the square root. So the things inside the square root are inside the function because the square root is the function. So this one is affecting our horizontal. So this is going to be a horizontal reflection. Or another way to say that is a reflection, a horizontal reflection will reflect over the y-axis. So the y-axis acts its mirror. Okay, so that algebraically is going to be an x's times -1, right? All right, and then lastly, the only thing we don't have right now is this +3 taken care of, which means we need to write it as left 3. Okay, so we've got a couple steps to do this time. Let's write out our parent function. I'm just going to do that down below, because I won't have space. So we got x root x. So 0, 1, 4, 9, 0, 1, 2, 3. Okay, and we'll transform those with the stretches, compressions, and reflections. So our x's are getting multiplied by -1. That's it. So 0, -1, -4, -9. Okay. And our y's are getting multiplied by 2. So if our y's are getting multiplied by 2, then they'll go 0, 2, 4, 6. And here we'll write out our form. So we had just double check. So we used up the 2 in front of the square root and the negative inside. So 2 negative x. Okay, so let's graph both of these and then do our translations. So for our parent function, 0, 0, 1, 1, 4, 2, 9, 3. Okay, so that's root x. Next up, we have our transformed function without missing the translation still. So 0, 0 again. -1, +2. -4, +4. -9, +6. That look right? Yep, looks good. Okay. So let's do that. All right, so do we have our reflection? Yeah, so we have our horizontal reflection, looks like it, and we have a vertical stretch we're twice as tall. Looks good. Okay, now all I have to do is move each of those key points left 3, down 2. So left 3, down 2. Left 1, 2, 3, down 1, 2. 1, 2, 3, 1, 2. And this last point, it looks like it makes it off of the edge of the graph. You can try to estimate where it would be if you would like, but it's fine to, if we have points off the edge of the graph, to just leave them. So we'll go like that. All right, and this is our, what did we call this one? G of x. All right, so that's it for today's lesson. There's some practice on the rest of the pages.